Okay, SIMA. So we are studying about Biot-Savart's law. What is Biot-Savart's law? See. So it gives magnetic field because of small current element. Small current element means here. So this is a small element of a wire. So this is the total wire. No? We are taking a small element whose length I can call it as dl dash. Okay, and dl dash is a vector quantity. It is not a scalar quantity. And how to find out the direction of this dl dash? To this wire, just you draw a tangent. Are you able to understand? Then this tangent direction is the direction of dl dash. And this dl dash, if you multiply by I, then it is called as current element. Clear, Nama? What is the amount of current which is entering I, no? Length of wire is dl dash. Therefore, I dl dash is what? I dl dash is called as current element. Clear, no? And Biot-Savart's law gives the small amount of magnetic field developed because of this small amount of current carrying element. Small amount of current carrying element doesn't exist. What is the reason? Current always flows in loops only, no? If you separate this one, current cannot flow. So this is a theoretical formula, but by using integration, we get the actual results. Are you able to understand? So because of this small current carrying element also, if I take somewhere here point P, which is at a distance of r from this current carrying element, so here definitely some magnetic field will be produced, no, because of this small current carrying element. Yesterday was what we studied, current carrying elements or current carrying wires, they produce magnetic field. This is what we studied. So therefore this current carrying element also will produce some magnetic field, where here I am taking at a point P, and angle between this dl dash and r dash is how much? It is theta. Okay, ma? So here at point P, this small current carrying element will produce some magnetic field. So that magnetic field dB, I call it as. dB means what? Differential magnetic field, very small amount of magnetic field. Clear, no? And this dB is directly proportional to IDL. Okay, ma? If the magnitude of IDL is greater, strength of magnetic field also will be greater. Are you able to understand? So dB is proportional to sine theta. It is not proportional to theta, it is proportional to sine theta. Clear, no? And this small amount of magnetic field, it is inversely proportional to r square. And what is r? R is the distance of this point P from the current carrying element. Clear, no? Combine all of them. If I combine all of them, what I will get? dB is proportional to IDL sine theta divided by r square. So this equation is called as Biot-Savart's law. Okay, ma? This we call it as Biot-Savart's law. So dB is proportional to IDL sine theta divided by r square. Okay, ma? And if I want to remove this proportionality symbol, I have to place a constant, no? And that constant is what? That constant is mu naught by 4 pi. So mu naught by 4 pi IDL sine theta divided by r square. So this is the total equation of Biot-Savart's law. Are you able to understand? Now see, here B is a vector quantity, no? Magnetic field is a vector quantity, no? For example, yesterday what we have studied, this is a magnet having north pole and south pole. Then magnetic lines, they travel from north to south outside the magnet. Clear? So for example, here if I want to find out the strength of magnetic field, what I will do? I will draw a tangent B dash. So B dash is a vector quantity. Okay, ma? So because B dash is a vector quantity, here also B dash will have a direction, no? So the magnetic field produced because of this wire will have a direction. So here if I want to find the direction, how can you find out? Cheppandi. Adi geese cheppandi. So here at point P, what is the direction of magnetic field produced by this current carrying element? Cheppandi. మీ అద్భుతమైన ఆన్సర్లు ఇస్తే నేను తరిస్తాను అనమాట. యూజ్ చేసి మీరు చెప్పాలి. Sima. So here Sima. So this is the direction of current, no? So first of all we use right hand grip rule, no? So hold this conductor such that curling of fingers, thumb is in the direction of current, curling of fingers will give the direction of magnetic field. So therefore, because of this current carrying element, can I say this will be the direction of magnetic line, orientation of magnetic line. Clear number when I hold this conductor and curl my fingers. So how I am curling? I am curling from this side to this side, no, out of the board. Out of the board I am curling from this side to this side. So this line I better represent with the thick line. Thick line indicates this is the magnetic line out of the board. And dotted line indicates magnetic line which is present inside the board. Are you able to understand me? So therefore, here I want to find out B dash, no? So here I will draw a tangent. So tangent will exactly go inside the board. That is how we find a B dash direction, no? So here there are two conditions. Now. First of all, finding the orientation of magnetic line. First orientation that I can calculate by using right hand grip rule. Orientation of magnetic line. Once I find out orientation, then where you want to find magnetic field? Here I want to find magnetic field direction. There you draw a tangent. Clear, no? So, magnetic loop is like this, no? This is how magnetic loop is present. Where is my point P? Point P is here. Clear, no? So, it is entering from this side to this side. It means magnetic field is entering the board. Magnetic line is entering the board. So, here you draw a tangent. So tangent is exactly perpendicular and inside the board. That is the meaning of it. Clear, Nama? So therefore what I say here B dash is perpendicular and inside the board. Clear, Nama? And if I want to find out by using cross product also, that also we can do. How we can find out Sima? Same equation I can write in vector form. In vector form, the same equation can be written like this. dB dash is equals to mu naught by 4 pi I into dl dash cross r dash divided by r cube. So this is writing Biot-Savart's law in vector form. Are you able to understand me? So now by using this vector form, can you say how to find out the direction of B dash? First of all, why we write in vector form? వెక్టర్ ఫామ్లో ఎందుకు రాస్తాము? ఏదైనా పర్పస్ ఉండాలి, మనకేమైనా పని లేకుండా ఉండాలి. టు ఫైండ్ అవుట్ డైరెక్షన్. క్లియర్, నో? సో బై యూజింగ్ దిస్ వెక్టర్ ఫామ్, హౌ కెన్ యూ ఫైండ్ అవుట్ ద డైరెక్షన్ ఆఫ్ బి డాష్ అట్ దిస్ పాయింట్ పి? కెన్ యూ సే ఎనీబడి? రైట్ హ్యాండ్ రూల్ ఫర్ క్రాస్ ప్రోడక్ట్. సో క్రాస్ ప్రోడక్ట్ ఈస్ ప్రెసెంట్ బిట్వీన్ విచ్ వెక్టర్స్? dl dash and r dash. That's all, Rama. So place your right hand on dl dash. This is my first vector, no? dl dash. Rotate towards r dash. Thumb is in which direction? Thumb is perpendicular and inside the board. That's all, very simple. Are you able to understand? By that method also you can calculate. So just you take the cross product of dl dash cross r dash. That gives the direction of magnetic field. Clear, no? Right. So therefore, cross product of dl dash cross r dash gives direction of what? Gives a direction of B dash. That's all. Understood, Nama? So this law is called as Biot-Savart's law. Okay? One of the most beautiful laws in physics. Okay. Sima. So first application of Biot-Savart's law. So this is a circular wire, or you can call it as a circular coil, which is carrying a current of I. Clear, Nama? And let radius of this coil is R, A, anything you can take. A also you can take. So because of this current carrying coil, exactly at the center of the coil, I want to find out magnetic field. Clear, no? So we have calculated magnetic field only because of current element, no? Small current element. Now I want to calculate because of this total loop. Are you able to understand? So what is the concept? Same procedure which we have adopted in Biot-Savart's law. First you select a small current carrying element. Clear, no? So this is I dl dash. And what is the direction of I dl dash? This is the direction of I dl dash. Clear, no? So from here, this is the point where I want to find out magnetic field, no? So draw radius vector up to here, r dash. Okay? Angle between I dl dash and r dash is how much? Exactly 90 degrees. Wherever you see, it will be 90 degrees only. For example, if you take a current element here, then this is the direction of current element, no? So from here also, the angle will be 90 degrees. So wherever you see, angle will be 90 only. So therefore, theta value is how much? Theta value is 90 degrees. Now apply the Biot-Savart's law. So dB is equals to mu naught by 4 pi IDL sine 90 divided by r square. That's all. So what is this dB? Small amount of magnetic field because of small current carrying element. Change that. Okay, ma? So if I want to calculate total magnetic field, what I have to do? Integrate on both sides. Clear, no? So integration and differentiation will get cancelled. So B is equals to integration of mu naught by 4 pi IDL sine 90 value is 1 divided by r square. Clear? So therefore, B value will be how much? B is equals to, what are the constants here? Mu naught by 4 pi I by r square. All of them, they are constants. Only dl is a variable. Clear? So just keep dl inside the integration. Remaining all of them you take out of integration. Mu naught by 4 pi I divided by r square integration of dl. Okay? So what is dl? dl is small current element. No? Integration of dl? Total length. Total length is how much? Total, pi r square. Wow. Length of this wire is how much? Circumference 2 pi r. No, my radius is already given. No, circumference is 2 pi r. Small length is dl. Integration of total length means total length of the wire. Total length of the wire is 2 pi r. Okay. So therefore, B is equals to mu naught by 4 pi I by r square multiplied by 2 pi r. So square and r get cancelled. So 2 pi 1s are 2 pi 2s are. So B is equals to mu naught I divided by 2r. So this is the equation to calculate magnetic field exactly at the center of the current carrying conductor. Are you able to understand, ma? And these formulae you should by heart them. Mu naught I by 2r. Okay. Now here we can write a case also, ma. Case is that if n number of turns are present, if n turns are present, if n number of turns are present, into n, that's all. This is only one turn, no? One turn. So like this, if you are making 3 turns, 4 turns, 10 turns, then because of every turn you will get this much amount of magnetic field. No? So if n turns are present, then magnetic field is equals to n into mu naught I by 2r. Clear, no? Or you can write mu naught n I divided by 2r. If there are many turns. Okay? That's it. Okay, sim. Second application we are studying magnetic field on the axial line. Axial line of a current carrying conductor. What is meant by axial line? So this is a current carrying conductor. This becomes the axial line. Are you able to understand? So on this axial line, somewhere here, I want to find out magnetic field. Clear? So let us see how we can calculate. Sima. Again, what is the procedure? First you take a current element. Okay, ma? So this is the small current element. Okay, ma? And here you remember, this coil is like this, ma. Coil is not like this. Coil is like this. Okay? So this coil, current carrying coil, half of the coil is inside the board, half of the coil is out of the board. Are you able to understand? And this axis is present on the board itself. Axis is present on the board. Half of the coil is inside the board, half of the coil is outside the board. Clear? And I am considering this side of the coil to be out of the board. This is the coil out of the board. And current is flowing in this direction. Clear, no? Therefore, here I will take a small current element, IDL dash. Okay? Now can you say, what is the direction of IDL dash? Cheppandi. Mari taristanu ingosari. Abba. Atlana itlana. Atle. Ela. How can you say? What is the direction of IDL dash? Sima. So this is the direction of loop, no? This is the direction of loop. Clear, no? So here I am taking a current element. And to this current element I have to draw a tangent, no? Tangent is like this. So what is the direction of tangent here? This IDL dash, clear, no, ma? So perpendicular and out of board. Perpendicular and out of board. Are you able to understand? So this direction I cannot draw outwards, no? So I am drawing like this. But it is not like this. It is perpendicular and out of the pole. Okay. Now what is the next step I have to do? Next time cheyali. Draw R dash. Here I want to find out magnetic field, no? So from the current element you have to draw the distance. So let us consider this is R dash. Clear now? Now anybody, can you say what will be the angle between I dl dash and R dash? Chappan. What is the angle between I dl dash and R dash? Okay. Let us call this angle as pi. Now can you say? 90 minus pi. ఇది ఒకటన్నా చెప్పండి నేను కాసేపు రెస్ట్ తీసుకుంటా. See. Now I want the angle between current element and R dash. This is what I want to know. See man. I dl dash is in this direction. No? I dl dash is in which direction? Perpendicular and out of the pole. This is the direction of I dl dash. Clear? Where is my P dash? Point P. Point P is somewhere here. Clear now? Point P is here. So connecting this I dl dash, this is my R dash. What is the angle? 90. Exactly 90. Ante cheppalsinde. Are able to understand? So therefore here angle is how much? Here angle is exactly 90 degrees. Are able to understand? Okay. Now see ma. This current carrying element, it will produce magnetic field here, no? Now what is the direction of that magnetic field? See ma. So this current carrying element produces magnetic field at this point, no? That direction of magnetic field I want to calculate. So by using which method I can calculate? Already we have studied, no? dl dash across R dash. This gives the direction of magnetic field. Already we studied, no? So what is the direction of dl dash? dl dash is in this direction. This is the direction of dl dash, no? This is my direction of R dash. Are you able to understand me? Exactly 90. Okay. So where I have to place my right hand? dl dash. Place your right hand on dl dash. Curl towards R dash. But R dash is not here, no? R dash is here. Okay. So what I do is, it is somewhat like this. Clear now? So place your right hand on dl dash, but R dash is like this. If I curl like this, then I can reach this R dash, this like this. So instead of keeping like this, I am bending it by a small angle. Okay, now I can curl towards R dash. So this is the direction of thumb. Are you able to understand? So thumb is in the plane of board only, but it is making small angle. Okay, so therefore what is my direction of dB dash? This is the direction of dB dash. Okay, and what is this dB dash? This is the magnetic field, small amount of magnetic field because of this small current carrying element. Understood now? Okay, now see. Now what I do is, in exactly opposite direction, I will take another dl dash. This is one dl dash. This is another dl dash. So because of this dl dash, second magnetic field will be in this direction. Now that direction I am not discussing. I hope you can understand. Are you able to understand? Ma? So this is the magnetic field produced because of this current carrying element. This is the magnetic field dB dash produced because of this current carrying element, I dl dash. Clear now? Now what I do? So if this angle is pi, this angle also will be pi only. So split this one into two components. So this is dB cos pi. Okay, ma? And this is dB sin pi. Are you able to understand? Similarly, this one also you split into two components. I can split like this, no? So this angle is pi. This angle is also pi. Clear, no, ma? So this is dB cos pi, and this is dB sin pi. What do you understand? I understand that dB cos pi and dB cos pi, they will get cancelled because they are exactly in opposite direction. No? Huh? But all dB sin pi's, they are in same direction. It means they will get added up with each other. And this is the point of magnetic field, no? So this is one dB sin pi because of one current carrying element. Another dB sin pi because of another current carrying element. So like this you can go on adding the dB sin pi's. Are you able to understand, ma? dB cos pi's, they're exactly in opposite direction, they get cancelled. But sin pi's, they're in same direction. So therefore, if you add all these dB sin pi's, you will get total magnetic field. And how to add them? Integration. That's all, no? So therefore, addition of all dB sin pi's will give net magnetic field, where at point P. Clear, no? And just I can say B is equal to integration of dB sin pi. That's all, no? Integration is nothing but addition, so add all the dB sin pi's, you will get the total magnetic field. That's it. Clear, no? Now what is dB? Already we know, no? dB we know by using Biot-Savart's law, mu naught by 4 pi IDL sin 90 divided by r square multiplied by sin pi. That's all, no? dB we know how to calculate, no? By using Biot-Savart's law. Mu naught by 4 pi ideal sin theta divided by r square. Theta value already we have discussed, it is 90. So here there are two angles, I should not be confused. One angle is angle between the current element and r dash. Another angle is angle made by r dash with this axial line. Two angles are there. Are you able to understand? Now here, which are the constants and which are the variables? dl is the only variable. Remaining all are constants. So take them out of integration. So mu naught by 4 pi I by r square, sin 90 value is 1 multiplied by sin pi, integration of dl. That's it. Okay. So integration of dl, pi r square. Integration of dl, same again, 2 pi a. Radius I have taken a, no, you can take r also, because already I have taken r here, I have taken a here. 2 pi a will be the total length, no, circumference. So therefore, b is equals to mu naught by 4 pi I by r square multiplied by sin pi. How can I write? Sin pi. Here there is a right angle triangle which is formed, no? Clear, no? Sin theta is opposite by hypotenuse. So opposite side is a, hypotenuse is r, multiplied by integration of dl. Integration of dl is 2 pi a. That's all, no? So therefore 2 pi 1 0, 2 pi 2 0. Make a note up to here. Okay. Sima. So therefore I got result up to here, no? Abba, rub chesnama. Sima. R is what? R is nothing but square root of a square plus x square, no? See in your figures. This is the coil, no, ma? This distance is x. This distance is a. This distance is r. So r is equal to square root of a square plus x square, Pythagoras theorem. So therefore, but here r square and r cube is there, no? So therefore r cube, how can I write? I can write a square plus x square power 1 by 2 power 3. Clear? So r cube is equals to a square plus x square whole power 3 by 2. This is how I can write. Now just substitute here. So therefore, b value is equals to mu naught I a into a is a square divided by 2 into a square plus x square whole power 3 by 2. Clear, number? So this is the equation to calculate magnetic field on the axial line of a current carrying coil. Okay. And here also you can write if there are n number of turns. We have taken only single turn, no? If there are n number of turns. So, case. If n turns are present. Okay, ma? Then B is equals to mu naught n I a square divided by 2 into a square plus x square whole power 3 by 2. That is my answer. Okay. And what is the direction of this magnetic field, ma? So this is the coil. Current is traveling in this direction. So here at point P, if I want to find out magnetic field, then this is the direction of B dash. Direction also you should not forget. Because all dB sin pi's, they were acting in this direction, no? So total magnetic field will be in the same direction. Is it clear? That's it. And this is the coil, ma. Don't think it is a magnetic loop. This is a coil. Clear? Now here, if I draw the graph of how magnetic field varies with respect to coil, let us see how I can draw the graph. See, ma. Yendra sound adu. Windows the board the Windows the na. Okay, see, ma. So consider this is a coil, ma, and this is the direction of current. And if I draw this graph, what is this graph? On y-axis I will take strength of magnetic field, and here I will take a distance x. Distance x is measured from the center of the coil only, no? Clear, no? Now can you say how this graph varies? By looking at this equation you have to say. So with respect to x value, plus x and minus x, both you can take. I have taken distance on this side, no? You can take distance in opposite direction also. On this side also field exists, no? Field exists on both sides. So this is minus x. Now can you say how this field varies by looking at this equation? Anybody? See, where x is present in denominator, no? So if x increases, denominator increases. If denominator increases, total value decreases. Clear, no? So therefore, the type of the graph will be like this. Clear? On both sides, graph will be like this. It means at the center, magnetic field is maximum. And as you move away from the coil on the axial line, field continuously reduces. Direct question can be asked on this graph. Have you understood, ma, how we have drawn? So x is present in denominator, no? And what is meant by x? Distance on the axial line. So if x becomes 0, then b value will become maximum. X becomes 0 means what? That is the center of the coil here. Clear, no? This point is the center of the coil. So at the center, field will be maximum, and as you move away from the coil on both sides, field reduces. Clear? Right. So therefore, what is the note point? I have to write note point is that at the center of coil, field will be maximum. Okay, ma? That's it. That is the point which we should understand. Okay, and let us do one thing. Let us calculate what is the field at the center. Okay, ma? So case field at center. Field at center means x value will be how much? 0. X will be 0 only, no? So therefore substitute 0 here, ma. So B is equals to mu naught I a square divided by 2 into a square plus 0 whole power 3 by 2. So therefore B is equals to mu naught I a square divided by 2 into a cube. So cube and a square get cancelled. So B is equals to mu naught I by 2a. Instead of IA, if I write R, mu naught I by 2R. Do you remember this equation? What is this equation? Mu naught I by 2R. Magnetic field exactly at the center of the coil. Here also we got the same result. Are you able to understand, ma? So just we have calculated on axial line, that's all. And if you place x is equal to 0, that is again exactly at the center of coil only, no? So center of coil, again you will get the same answer, mu naught I by 2R. Okay? Right. Okay, ma? Sima. So next we are discussing about magnetic field because of straight current carrying conductor. Ma. So this is a current carrying conductor. So somewhere here at this point P, I want to find out the strength of magnetic field. Clear, no? And what is the distance of this point P? It is present at a distance of A, let us suppose. Now from this point P, you have to draw the end lines. End lines. End line means what? From this point, you draw a line to one end, and from the same point, you draw another line to another point, another end of this wire. Clear now? So this one is making an angle of theta 1 and second end line is making an angle of theta 2. Clear? Then at this point P, magnetic field is given by mu naught by 4 pi. Derivation I am not doing, man. Any derivation chestam chalu. Mu naught by 4 pi I by A into sin theta 1 plus sin theta 2. So this is the equation to calculate magnetic field because of straight current carrying conductor at point P at a distance of A. And this point is making how much angles? Theta 1 and theta 2. And where I am taking angles? Angles are taken between end lines and this distance. Are you able to understand? Same equation I can write like this also. For example, if I consider this angle as pi 1 and this angle as pi 2, then my equations will change. BP is equals to mu naught by 4 pi I by A into cos pi 1 plus cos pi 2. Okay, ma? Be careful about these two equations. So if you are taking angles here, then I have to write equations in terms of sine. If I take angles here means where angle between conductor and end line. Conductor and end line, then equation converts in terms of cos. This is understandable, no? If this is pi, this is 90 minus pi. This remaining angle is, this is 90. This is 90 minus pi 2. Let us take this as pi 2, this as pi 1. Clear now? So 90 minus pi 1 is cos only. No? Like this you can write. So this angle, if you write in terms of sine, if you write these angles, then it should be written in terms of cos. Okay. Now we write some cases in the same current carrying conductor. Clear now? First case is infinite wire. Okay. What is meant by infinite wire, ma? Length of the wire is very large. So if length of the wire is very large, can you say, how can I calculate magnetic field because of that wire? Okay, ma? So this is an infinite wire. It is infinite on one end, it is infinite on another end also. So here at a point P, at a distance of A, which is carrying a current of I want to find out magnetic field. Anybody, can you say how can I do it? See, ma'am. If length of this wire becomes very large, then what happens to these two angles? See, ma'am, consider this is the length of the wire. So if I draw angle like this, then this angle is increasing. No? Similarly, if I increase the length of this wire, then what is happening to this angle? This angle also increases. Clear? And they can increase up to which level? Maximum 180. They can increase maximum up to 90 only. Are you able to understand? Ma? See here, if wire is very long, from here if you draw the wire, it cannot go like this, no? It should go, maximum it can go in a straight line. Straight line means what is the angle it can make? 90 degrees. Are you able to understand, ma? So therefore, consider wire is somewhere here. And if you go somewhat like this and join somewhere there, then this angle will become almost 90 degrees. Are you able to understand, ma? Similarly, this angle also will become how much? 90 degrees. Okay. So therefore, theta 1 is equal to theta 2 is equal to 90 degrees. In which condition, ma? If wire is infinite wire. So therefore, substitute in this equation, sin 90, 1, another sin 90, another 1 plus 1, 2, that's all. That is my equation. So therefore, magnetic field at a point P is mu naught by 4 pi I by A into 1 plus 1. So therefore, mu naught by 4 pi 2I divided by A. So you can write in this method also, or you can cancel 2 with this 4. Then the equation becomes mu naught by 2 pi I by A also. You can write like this also. Okay, ma? So therefore, this is the equation to calculate magnetic field because of infinite wire. Okay, ma? Right. See, ma. So magnetic field because of semi-infinite wire. Semi-infinite wire means what? We know one end of the wire is present here, and second end where it is, we don't know. It is very long. Clear, Nama? And where we are placing point P, where I want to find out magnetic field at one end of this wire. Clear, no? And it is making how much perpendicular distance? A. So remember, A is always perpendicular distance. A is what? Perpendicular distance from wire. It should always be perpendicular only. Clear? So therefore, Sima, one end line if I draw to an infinite wire, one end line will be definitely 90 degrees, no? Clear, no? And if you draw one more end line, and this end line is present on the perpendicular distance only, no? So angle between both of them will be 0. Clear? So therefore I can say theta 1 is 0, theta 2 is 90 degrees. Where we are taking the angle actually, if this is point P, clear, Nama? We were taking angle here, no? Okay? And instead of drawing this end line here, if I draw the end line here only, this angle will become 0. So that's why one angle is 0, another angle is 90 degrees. Clear? So substitute in the equation. So therefore magnetic field at point P is mu naught by 4 pi I by A multiplied by sin theta 1 plus sin theta 2. So therefore it is mu naught by 4 pi I by A multiplied by sin 90 plus sin 0. Sin 90 value is 1, sin 0 is 0. So therefore it is mu naught by 4 pi I by A. This is my answer. Clear? No? So this is the magnetic field because of semi-infinite wire and point P present at one end of the wire. That's it. Clear, ma? See, ma. So let us calculate magnetic field because of these structures which are given at a point P, ma. So 1, 2, 3, 4 problems are given. So this is a current carrying conductor, ma. Here at a point P at a distance of R, I want to find out magnetic field. Anybody? 0. Enduku 0? See, for example, you take IDL dash. This is DL dash direction. No? If I take a small current element, this is DL dash direction. Clear? And from DL dash, you have to draw R dash also, no? R dash. So what is the angle between DL dash and R dash? 0. Okay, ma? So angle between DL dash and R dash is 0. Then what is the equation to find out magnetic field? Mu naught by 4 pi I by A into mu naught by 4 pi IDL sin theta divided by R square. Clear, no? Sin 0? 0. So therefore total magnetic field will become 0. Okay? It means exactly at the front of the wire, current carrying wire, magnetic field cannot exist. Magnetic field is 0. Clear? Second one? That would 0. That is also 0. Sima. Again same type of discussion for second one also. This is DL dash, no? This is DL dash. Clear, no? And from this DL dash, you have to draw R dash. This is the direction of R dash. So angle between DL dash and R dash is how much? 180 degrees. Sin 180? Sin 180 is 0. So therefore again magnetic field will be how much? Again magnetic field will be 0. Clear? Third one. Third one, can you say how can I solve? See. So did we study this type of shape? Iటువంటి shape ఏమైనా స్టడీ చేసినామా? No. So therefore what I can do is divide this figure into 3 individual components. Okay, ma? Divide this figure into 3 individual components. So first component is AB, second component is BC, third component is CD. Okay? So magnetic field because of AB will be how much? Anybody? Strength of the current is I and the distance of this point is A. How much? 0. Why? Just now we have studied, no? Clear, no? If this is the current carrying conductor, if you place any point P at a distance of R, then magnetic field will be 0. So this point P is exactly in front of this AB, no? So therefore, because of that, magnetic field will be 0. Okay. Now, can you say what is the magnetic field because of CD? It is also 0. Why? It is behind that one. Wire ki venakal undi kada. So this is the second condition we have studied. That is also 0. Magnetic field because of BC, this wire, this what you call half circle. Magnetic field because of total coil, do you remember? Magnetic field because of total coil is, chudandi, mu naught I by 2R. That's all, no? If magnetic field, if a coil is complete, then this is the equation of finding magnetic field at point P, mu naught I by 2R. But how much coil is present? Only half. So magnetic field also will be exactly half only. Are you able to understand? That's all. So therefore, magnetic field at point P is how much? It is vector sum of BAB plus BCD plus BBC. Why we are taking vectors? Because magnetic field is a vector quantity. Are you able to understand? So therefore, 0 plus 0 plus mu naught I by 4R. And what about the direction? No? Direction. How can you say? So for this we have a separate rule. See, for closed figures, this kind of figures, or you can say this kind of figures, any kind of figure, all these are closed figures. No? So if this is the direction of current, okay, then place your palm in front of this what you call figure, and you rotate your fingers in the direction of current. Are you able to understand? Then what is the direction of thumb? That will be the direction of magnetic field. Clear? See here. Now because of this coil, can you say what is the direction of field? Perpendicular and inside the board. This palm you can place at the back of this coil also, no problem. Either you can place at the front or you can place at the back. Curling should be in the direction of current. Are you able to understand? Then magnetic field is perpendicular and inside the board. And that direction, I can call it as minus k cap, no? Clear, no? So therefore, this is the direction of magnetic field at point P. And magnitude wise, it will be that much. Okay? So therefore, magnetic field at point P is how much? It is minus mu naught I k cap divided by 4R. Okay, ma? And what is this rule called? This rule is called right hand palm rule. We will write it separately. Okay, ma? Now can you say fourth one? Fourth one. Chapandi. Again you divide this one into three parts, ma. A, B, C, D. Okay. So magnetic field because of AB, 0. Magnetic field because of CD, 0. Magnetic field because of BC. So this is only 1/4 of coil, no? So I will write 1/4 of mu naught I by 2A. I have taken A, no, ma? You better take R here. Because every calculation I have done in terms of R only. This I have taken in terms of A, no problem. So therefore, net magnetic field will be how much? So now can you say because of this coil, what is the direction of magnetic field? This is also perpendicular and inside the board. So place your right hand, palm, rotate in the direction of current. Magnetic field is perpendicular and inside the board. Clear, Nama? So therefore, BC dash is equals to how much? Minus of mu naught I by 8A. This is my answer. That's it. Okay. So after writing this, we will write right hand palm rule. Right hand palm rule. Okay, ma? So place the right hand palm in front or back of coil and rotate the fingers in the direction of current. In the direction of current. Okay, ma? Then thumb gives the direction of B dash. Thumb gives the direction of B dash. That's it. Are you able to understand? Okay, ma? Now here what is the direction of B dash? I am placing my right hand and curling like this. Thumb is perpendicular and inside the board. So therefore B dash is perpendicular and inside the board. That's it. Clear, ma? Right now. So Sima, let us see this question. So find the magnetic field at point P here. Okay. So yesterday we have done one method, Nama. What is that method? Divide this figure into many small parts. Okay. Then find out magnetic field because of each part. So A, B, C, D, E, F. So these are the different parts I am taking. Okay. So magnetic field because of AB, 0. Bolo ji. 0. So magnetic field because of DF, this is also 0, no? What is the reason, ma? So to line AB, point P is in a straight line. Similarly to point DF also, point P is just behind that one. So magnetic field will become 0. Then what is the magnetic field because of BCD? How much? Magnitude. Magnitude చెప్పండి first. Try to say the magnitude. So it is half of mu naught I by 2R. Instead of R I have taken A, nama, so 2A. So why I have taken half only? Only half loop is present, no? But this is wrong. Tappidu. This is wrong. There should be some correction here. What is the correction? This is current I, no? This is half loop, this is half loop. So when this current reaches this point B, it is seeing 2 loops, no? So current divides like I by 2 and I by 2. That's all, no? So instead of I, what I am supposed to write? I by 2. Only half of the current is flowing through each loop, half of the loop. Clear, no? So therefore it is how much? Mu naught I by 2 2s are 4, 4 2s are 8, 8A. Okay, ma? And if I want to write the direction, what is the direction of BCD? Right hand palm rule. This is how we use the right hand palm rule, no? So place your right hand palm in front of this coil and rotate your fingers. Thumb is perpendicular and inside the board. So therefore BC dash vector is equals to minus K cap. This is the answer which I got. Now what about this loop? Magnetic field because of BED. This one. Magnitude wise is same, no? Current is same, length of the loop is same, everything is same. So magnitude wise it is also mu naught I by 8 into A. Clear, no? Direction perpendicular and outside the board. Why? So now previously we have placed right hand palm like this, no? Now we place the right hand palm like this. Why? Because the curling of fingers should be in the direction of current. Thumb is perpendicular and out of the board. So plus K cap. Clear, no? So I see that one magnetic field is exactly inside the board and another magnetic field is exactly out of the board. So magnitude wise they are same. So they will get cancelled with each other. So therefore net magnetic field is how much? It is equal to 0. That is our answer. Clear? Try to do this one. Adi cheyandi ippudu. See this question. Next question. So now this is the given arrangement, ma. This is a loop. Clear? So current is entering from here and current is leaving from here. Are you able to understand? So exactly at the center of this loop, I want to find out magnetic field. Now you see how this current divides. Previously in this condition, how current has divided? No? It has divided into exactly half, no? Why? What is the reason? Resistance is exactly same, no? So already we studied that previously. Resistance is directly proportional to length. We studied in current electricity, no? So if resistance is same, current divides equally. Clear? But in this condition, so this wire is a bigger wire, this wire is a smaller wire. If I call this length to be L, this length I should call 3L, no? Clear, no? So therefore, can you say how current divides? Will it divide equally? Or how it divides? Ela divide avutundi? So totally I can say 4 L's are there, no ma? 4 L's are there. Or I can say 3L, L. So resistance is directly proportional to length, but I is equals to V by R. I is inversely proportional to resistance. This we know, no? So if resistance is greater, current should be lesser. Are you able to understand? So therefore I can say I1 by I2 should be equal to R2 divided by R1 because they are inversely proportional. Are you able to understand? Okay, ma? So therefore let us call this current to be I1, ma, and let us call this current to be I2. So therefore I1 by I2, how can I write? R2 divided by R1. This is R2, no? And this is R1. Okay. So R2 value can I write? It is just R only. Okay, ma? And R1 value, can I write? It is 3R. Can I write like this? Length is very small, no? So resistance also will be very small because resistance is directly proportional to length. Are you able to understand, ma? Here length is how many times bigger? 3 times bigger. So resistance should be 3 times greater when compared to this resistance, no? So R1 will be 3 times of this resistance, 3R. Satisfied? Clear, no? So therefore cancel R and R. So therefore I can say I1 by I2 should be equal to 1 by 3. Clear, no? So ratio I got. And also we know that I1 plus I2 is how much? I1 plus I2 is I only, no? Are you able to understand? And I1 by I2 I got it as 1 by 3. So therefore what I can write? Can I write from here? I can write I1 is equals to I2 by 3. I can write this one, no? Take this value and substitute here. So I2 by 3 plus I2 is equal to I. Clear, no? So 4I2 is equals to 3I. So therefore I2 is equals to 3I by 4. Understood, no? So what is the amount of current flowing in this branch? 3I by 4. Then what is the remaining current? I by 4. That's all, no? So therefore in this branch the amount of current flowing is 3I by 4. And in this branch the amount of current flowing is I minus 3I by 4, which is I by 4. That's all. Now once I know the currents, very easily I can calculate the magnetic field, no? Clear? Now come on. Now do the calculation. Okay, ma? Now we name this figure once again. We know that magnetic field because of this wire and this wire is 0. Clear, no, ma? Because it is in straight line. Just I take this is A, B, C, D. Okay, ma? Let us call magnetic field because of A, B, C. Okay, ma? Magnetic field because of A, B, C is how much? It is 3 by 4th of mu naught I1 divided by 2A. Can I write like this? So this is the total loop, no? In this total loop, this part is how much? 3 by 4th. So only 3 by 4th of magnetic field will be present. So 3 by 4th of mu naught I by 2R. Okay? And I value already we have calculated I by 4. So substitute here. So it is a 3 by 4 multiplied by mu naught into I by 4 divided by 2A. Clear, no, ma? So therefore 3 mu naught I divided by 16 2s are 32 A. This is the magnetic field because of ABC. Are you able to understand? So therefore magnetic field because of ABC is equals to how much? 3 mu naught I by 32A minus K cap. Because it is towards negative Z axis, no? Clear? Similarly, now we calculate magnetic field because of ADC. Okay, ma? Magnetic field because of ADC. Lower circuit, this circuit. Now come on, try to say the value of this one. How much loop is present? 1 by 4. Idi kadara 3 by 4. This is 3 by 4, this is 1 by 4th loop only, no? Huh? So 1 by 4th of mu naught I2 divided by 2A. Clear number? I2 value 3I by 4. So 1 by 4th of mu naught into I2 value is 3I by 4 divided by 2A. Clear? So magnetic field because of ABC is how much? So 3 mu naught I divided by 4 4s are 16, 16 2s are 32A plus K cap. Okay? That's it. Is it clear? Now can you say what is the total magnetic field? 0. Logic good చెప్పాలి. లాజిక్ ఇదంతా చేసి చెప్పినవరా? అబ్బా ఎట్లా వస్తుంది డైరెక్ట్గా? కానీ వాల్యూస్ అంతా వేరు వేరుగా ఉన్నాయి కదా. కరెంట్ డివిజన్ వేరు అంతే అంటావా? సరే, ఓకేమా? సో దేర్ ఫోర్ net magnetic field is how much? It is 0. Clear number? Why it is 0? One magnetic field because of ABC is inside the board. Magnetic field because of ADC is out of the board. So magnitude wise they are same. So they get cancelled with each other. Are you able to understand, ma? So make a note up to here. See, ma. So therefore what we studied, if there is any closed loop, and if current divides, are you able to understand? Then magnetic field because of that closed loop will be always 0. Whatever may be the type of division. Are you able to understand, ma? So previously what we studied, this is what we studied, no, when current is dividing like I by 2 and I by 2. Then also here at this point magnetic field is 0. Clear, no? Similarly, if this is the loop, clear, no? And if current gets divided like this, then also at the center magnetic field will be how much? Magnetic field will be 0. Clear, no? Similarly, if you take a square shaped loop or any type of loop, so current is again getting divided like this. So if this is I, consider this is I1 and this is I2. Then also magnetic field at center will be how much? It will be exactly 0. Are you able to understand, ma? So these type of questions are very common, ma. So if this type of figure is given, without calculation you can say magnetic field at the center is 0, irrespective of shape of the circuit. Whatever may be the shape of the wire given, if current divides in a loop, then magnetic field will become 0. Clear? Right now. Make a note of that point. Okay, ma? So in a closed loop, if current gets divided, then magnetic field at center will be how much? It will be 0. Whatever may be the shape of the loops. So this loop shapes also you draw. Clear? Irrespective of that, it is always 0. Sima, this is the question. So a proton is moving northwards. Proton is what kind of charge? Positive charge, no? So it is moving in this direction. So consider this is north, south, east and west directions. And what is its velocity, ma? Velocity is equal to 5 into 10 power 6 meters per second. In a magnetic field of, this is the magnetic field. Okay, ma? And magnitude of magnetic field is how much? 0.1 Tesla. then we are supposed to calculate this charge will experience how much force. Force experienced is how much? Can you say? So, force experienced by charge placed in a magnetic field. That is nothing but magnetic Lorentz force. No? Clear, Nama? Formula? QVB sin theta. Charge is how much? Proton. Proton charge 1.6 into 10 power minus 19. Velocity 5 into 10 power 6. Magnetic field 0.1. Theta sin 90. Angle between field and velocity is 90 degrees only, no? So sin 90. Clear, Nama? So just do this calculation. That is my required answer. Answer is 8 into 10 power minus 14 Newton. Okay, ma? This much amount of force is experienced. Okay. Similarly, can you say this charge will experience force in which direction, ma? Out of the board. How can you say? Fleming's left hand rule. Cheyi petnavu kada. Ma chustanu right or left are. Fleming's left hand rule. So in Fleming's left hand rule, what does index finger indicate? Direction of magnetic field. Clear, Nama? Middle finger, velocity. Velocity. Then thumb is in which direction? Perpendicular and inside the board. So that is the direction of magnetic Lorentz force. So just I can write F dash is equals to 8 into 10 power minus 14 minus K cap. This is how I can write. This is the direction of force. Fleming's left hand rule. In magnetic effects of current, always we use Fleming's left hand rule, remember. So in magnetic effects, Fleming's left hand rule. In electromagnetic induction, we use Fleming's right hand rule. Okay? See, ma'am. So a copper wire has 1 into 10 power 29 free electrons per cubic meter. What is that, can you say? What is meant by 1 into 10 power 29 free electrons per cubic meter? That is called number density of electrons. Number density of electrons. Okay, ma? Which is represented by n. So n value is how much? 1 into 10 power 29. Clear, no? So what is the cross-sectional area? Cross-sectional area is 2 mm square. Or I can write 2 into 10 power minus 6 meter cube. Clear? And what is the amount of current it is carrying? It is carrying a current of 5 amperes of current. Then wire is placed at right angles to a magnetic field. So for example, if this is the magnetic field, current carrying wire is placed like this. Then calculate the force acting on each electron. So which force each electron experiences? It experiences magnetic Lorentz force only, no? So Fm is equals to QVB sin theta. Theta value? Theta value is 90. Okay, ma? So Q, charge is there, charge on each electron. Each electron charge is how much? 1.6 into 10 power minus 19. Velocity. What is the velocity of each electron? Is it given? Then how can you do? He is asking force acting on each electron only, no? In this wire electrons are flowing. Current flowing means electrons are flowing. Then what is the force experienced by each electron? What is the velocity of each electron? How can I calculate? We have this relation, no, ma? I is equals to NEAVD. In current electricity we have studied, no? So from this I can calculate the drift velocity of electrons. I divided by NEA. What is the strength of the current? 5 amperes. Number density is how much? 10 power 29. Charge of electron is how much? 1.6 into 10 power minus 19. Okay, ma? Multiplied by area of cross section is 2 into 10 power minus 6. So from this I can calculate drift velocity. So take the drift velocity and substitute here. Clear, no? V means velocity, no? Velocity means which velocity? Drift velocity of electrons. The velocity with which electrons are moving. Clear? Multiplied by this drift velocity, I will write and substitute here. What is the strength of magnetic field? 0.15 multiplied by theta value, sin 90. Sin 90 value is 1. Okay? Calculate this one, substitute here, then do this total calculation. You will get the force experienced by each electron, single electron. Answer is 3.75 into 10 power minus 24. That is our answer.